many numbers of road accidents, of course, can be reduced by controlling some factors. So one factor, most important factor, is pavement skid resistance. Okay, now as a pavement engineer or materials engineer, we can do one thing, like we can check our pavement surface material properties so that it can give proper skid resistance, right? Now this pavement skid resistance has basically two components. I mean, based on those two components, we can predict the skid resistance, right? So they are basically microtection and pavement macrotection. Now, from the previous literature or the previous publications, it is already established that there is a very good connection between coarse aggregate properties and between pavement friction properties, I mean skid resistance properties. So here also from the diagram given by FHWA 2006, you can see that again they are saying pavement skid resistance has strong influence. It can be like predicted from microtection and macrotection of pavement, right? So my research objective was, the broad aim was to investigate how the different properties like mineralogical properties, morphological properties of coarse aggregate affect the microtection and macrotection of bituminous pavement surfaces, and subsequently what is the relation with skid resistance of pavements with them. This study also proposed image-based indicators, because it is not always easy, right, to get the microtexture property and macrotexture property. So because it needs, I mean, a very high-tech equipments. So to avoid that, or as an alternative, image-based indicators were also proposed that can be used reliably to predict skid resistance. Now, to achieve this broad aim, there are some specific objectives through which it was obtained. So the first objective was to determine how aggregate mineralogy impacts microtection and microtection deterioration rates. Now, point 2 is to evaluate various image-based indices that accurately describe the microtection and macrotection components of pavement surfaces. Coming to the final sub-objective, which was to develop statistical empirical models to predict initial pavement skid resistance based on the properties what we observed in the previous, objectives, like from the image-based methods and mineralogical properties like that. So in my PhD, the entire research work I divided into 4 major phases. The phase 1 was about to know the effect of aggregate mineralogical properties on microtexture deterioration. Why it is important? Because microtexture may be some particular aggregate source is having good microtexture, but it is from that we cannot say that it will sustain over time. So that's why the rate of deterioration of microtexture is very, very important. Now, this is all about the phase 1. I'll come to the detail. Now, the phase 2 is about identification of the image-based indices. How using image analysis we can check what is the microtexture value of a particular aggregate, because aggregate microtexture is the, that only depicts what is the pavement microtexture. Now, in phase 3 is identification of indicators for pavement macrotexture component. So for that, for macrotexture component, what we have done, before these two phases, phase 2 and phase 2, phase 1 and phase 2, sorry, these two phases are basically laboratory based experiments, and then some conclusions, observations were there based on the results. But phase 3 and phase 4 was related to field data and the actual pavement data. So in the phase 3, what I have done, there was again 2 parts. So in the first part, what I have done, to check the morphological properties of coarse aggregate, some laboratory equipment I have used, and then before construction of the pavement. If you want to know what is the macrotexture, it may provide before constructing the pavement, that also we should know, right? So for that, what I have done, I have checked the indicators such as aggregate shape, angularity, gradation, and then I have validated the results with and very easy technique. I mean, very easy setup is there. Uncompacted void content of course aggregate. Using that, I have just validated the results. That is before construction. And after construction, what I have done, after construction, I have collected directly the pavement images. And then with the pavement images, I have done image analysis. Similarly, to validate the results, what I have observed from the image analysis, to check the correctness, what I have done, two methods I have used. One is sand patch method, other one is simple, I mean, profile like laser based method. So from that, two indicators were observed and determined. Those are MTD and MPD. So mean texture depth from sand patch method, and the other method is mean profile depth. Now coming to the final phase of this study, which is about prediction of initial pavement skip resistance. So for that, collection of continuous pavement skip resistance data was done using skidometer BV11. So this field equipment we have used to collect the friction data, and then based on the results what we have observed from the aggregate morphological and mineralogical properties, we have developed models like using the image-based indices of pavement microtection and macrotection. Now coming to the phase 1, which is about effect of aggregate mineralogical properties on microtection and microtection deterioration. So for that, what we have done, like so in my study, I have collected 14 different aggregates from 14 different sources. They are nearby to West Bengal, but some other states like Telangana, Hyderabad, and I mean Telangana, AP, and Odisha, and also from Northeast also one source is there. So after that, after collecting the aggregate sources, what for mineralogical test, what I have done, I have prepared thin sections. Okay, so these thin sections were kept under two conditions, under optical microscope. Two conditions were, under two conditions, we have evaluated what are the minerals present. So one is plane polarized light, another one is cross polarized light. So why we have done that? Because based on the change in optical properties in these two stages, we can actually identify what is the mineral present in a particular aggregate source. So likewise, we have we have got the information, and we could identify all the sources, what is the basically the major mineral or the other minerals present. And this information I validated from the results of SEM, scanning electron microscope. You can see here that is based on the chemical formula. So spectrums are there, right? 4 different spectrums, and suppose in one case I have found that it is showing suppose you consider spectrum 2, then you can see that only silicon is there, right? So silicon is, if it forms oxide, then it will be quartz, SiO2. So that means here SiO2 is there. Similarly, some other minerals were also identified, like feldspar. Okay, so feldspar and quartz were the two more means abundant minerals in this particular source of aggregate. Now, likewise, some other minerals were also present. Now, the thing is, based on the minerals identified, what we have done ultimately, based on the minerals identified and their proportion, what is the proportion? I mean, how much is the quartz percentage? How much is the pyroxene percentage in case of basalt? So those I have, after identification, all those parameters like proportions and all, different other mineralogical parameters were identified with the help of that proportion. So what are the parameters? Relative hardness, relative specific gravity, degree of crystallization, degree of tectonization, alteration, number of minerals. Number of minerals means in a particular source of aggregate, how many different minerals are there. So you can see, like in some cases 4, 3, even 6, 6 is also there. It's like that. Now percentage of quartz, it is very important because we have seen that percentage of quartz is having more influence on aggregate polishing. So it is giving some resistance to polishing. Another parameter is differential hardness, right? Now another two parameters were also identified, feature from mineral size. So now we got the idea, okay, some minerals are there. Then what is the effect of the mineral size, not the aggregate size? Now, two size parameters were identified. One is SVI, another, that is size variation index, means what is the difference, what is the variation in size, whether it is there is huge variation, very small to very high, very larger size of minerals, or it is very close like that. And also D50, the median of the size. So for that, what I have done, I have used one as advanced equipment, that is ACM EBSD with electron backscatter diffractor. So from that, what we have done, two maps we could see. One is orientation map. On the top you can see rightmost corner, and below that the phase map is there. So again, from the phase map we can actually confirm two major phases, and from the orientation map we will get the idea of a particular mineral size, right? Now this is all about the mineralogical parameters. I have just briefed. Now, what is the relation between aggregate mineralogical parameters and microtexture and microtexture deterioration? So, how we have checked or simulated the microtexture deterioration in laboratory? So for that we have used polishing test, accelerated polishing machine, and we have polished the aggregate samples for based on the standard BSEN 1097. So actually what they have given one parameter which is polystone value. So for that, what they do, they just see they just take the last, the final polished value, final polishing level, and then based on that, some correction factors are there. Then they calculate the PSV. Even also, you can see that Indian standard is also giving PSV should not be less than 55. But from our study, what we could observe that PSV may not be a good indicator, because see, it is only taking the last, or the final or residual polishing, but we don't know about the what is the rate of deterioration, right? If we polish more, how it will react, that we don't know. So for that, what we have done, we have checked hourly basis, like what is the change, and one parameter BPN3 minus BPN6 means so for standard cases, what we do, 3 hours is conditioning phase. That we polish the aggregate samples. You can see, right, the coupons are there, and we have placed around the field, and then we polished using some abrasive chart. So first 3 hours for conditioning the samples, we polish it through using corn MD. Okay, it is like corn MD paper is there, so the same material, dust. And for the another 3 hours we use floor MD. So what I have done, I did not consider the conditioning phase, because it is important to remove the dirt and resin from the surface. I have just taken the changes in polishing phase. So the BPN3 minus BPN6 I have taken, right? Now it is observed that all the mineralogical parameters, almost all the mineralogical parameters is having good, better correlation with BPN3 minus BPN6 as compared to PSV. you can see from the chart that I have just shown here some correlations only. So BPN3 minus BPN6 versus RHD, relative hardness, it is having more correlation. And mind it that the black points, data points, are considering all the samples in this. But when the blue data points you can see in on the three charts, they are only for igneous samples. So already I have identified, right, igneous, metamorphic, and basalt. So in these cases, blue means only igneous I have taken. So this is all about aggregate mineralogical parameters and how they are impacting polishing behavior of aggregate or microtexture deterioration. Now coming to the phase 2. So how we can quantify the aggregate microtexture or deterioration. So for that, what we have done, we have taken coarse aggregates of particular size, 8 mm passing and 10 mm passing and 8 mm retaining, and then we have cleaned it thoroughly. Because why it is important? Because now in this phase all the studies are related to microscope, right? So any dart or anything on the surface will cause some problem. So for that, after cleaning thoroughly, what we have done, we have checked the initial microtexture before polishing, and then in the same way what I have presented in the previous slide, I have polished the samples, and then how I have broke, you can see, and then I just got the materials after polishing, and then again I checked under ACM, scanning electron microscope. So from both the cases, I took ACM images before polishing and after polishing. One sample set of image I have provided here. All the images I took at same condition, like 100x magnification, luminance, and other factors like other image factors, I kept constant for all the images, for all the samples throughout. And then to quantify the aggregate microtexture, I have carried out, I have selected 3 image analysis techniques. So 2 were statistical techniques. One is GLCM, other one is histogram. So in histogram, you can see for the same sample, I have shown the histogram results here. So, sorry. So before polishing and after polishing, you can see that there is a change in standard deviation as expected, right? So after polishing, the standard deviation is less as compared to before polishing. Now, from the histogram, it was observed that the standard deviation is the good measure of aggregate microtexture change. Similarly, GLCM method, gray level co-occurrence matrix, another image analysis method that I have used, and then 5 other parameters were identified. Now coming to the other method, which was basically wavelet analysis, and it is a transform based method. Okay, so in this case, what we have done, ACM images, the original images were decomposed into multiple levels. Okay, so maybe this will be a little bit difficult to understand. I'm just discussing in brief. So what we have done, we have just decomposed the images. In this case, what happens is the low resolution image is obtained, okay, by iteratively blurring. And at the same time, what happens, the finer details gets eliminated from the image. Only the coarser details will remain. Now, in this way, what we have done, actually based on the original image pixel dimension, suppose in this case, the pixel dimension was 1000 by 1200, like that. So for that, there is we can calculate the maximum level of decomposition, right? So here in my study, it was maximum decomposition level was 8. Now, using this formula, surface texture index was calculated. And like at each decomposition level, we got some decomposition coefficient. So from that, we just got the STI value, surface texture index value. Now you can see I have given in this table the results before polishing and after polishing, and it was observed that, as I mentioned, that total 8 levels were there, right? But initial some levels and final levels I did not consider, because lower levels were generating sufficient like it was not okay, because it could not reduce the noise effectively, and the upper, I mean the higher level of decomposition levels, it gave unreadable output due to loss in information because it was very much blurred. So what we have done, we have only taken third to sixth, and again in that we can see that only fifth decomposition level was giving very good result. Now how we have validated this image based method? So for that, what we have done, we have selected one equipment like 3D optical surface profilometer. So using that, we have just checked, okay, what is the surface average roughness in 3D before polishing and after polishing, and also we have calculated what is the differential polishing. Okay, so similarly for the this method also, we've let fifth decomposition level what we have ultimately taken for the analysis. For that also, before after we have considered and the difference. So you can see from the charts that I mean there is a good correlation between these parameters. So from that, we can understand that our method can be used to reliably estimate the surface texture index, right? Now coming to the phase 3, which is about macro texture components. So as I have already mentioned, there were two phases. What are the two phases? One is before construction. So for before construction, what we have done, we have prepared some laboratory setup. Okay, so you can see in the leftmost corner that is the setup, a very simple setup, a cardboard which was closed, and from the top inside that on a paper I just kept one individual particles and took images from the top using top light and camera, right? So all the individual aggregate images I have collected for aggregate to study the aggregate morphology. So from these I have determined shape index and angularity index. So for shape index, what we have done, first the images we have captured and then boundary was detected. Then after that, selection of smallest circumscribed circle was done using Welzel algorithm, and then selection of biggest inscribed circle was also done using Voronoi cell concept. Then from the difference of these, from the ratio of these two, we got the 2D shape index, right? So you can see that here I have given some representative images along with their SI values. So if it is rounded, it is close to round particle, then the SI value is less, and when it is very irregular in shape, it is more, the SI is more, right? Now coming to the aggregate angularity index. So for that, what we have done, so similarly, the same image was used and then it was pre-processed, and then one maze grid was created and centroid was also determined. Then from the centroid, what we have done, boundary to centroid, we have taken the radial distances and the difference in radial distances. So by that, calculating that difference, we could actually understand the, okay, what is the deviation? So what is the angularity? So for that, literature suggested some angles. So here in my study, I have taken 5-degree deviation and the radial distance, how it is changing. So similarly, similar to shape index, you can see that angularity index is also which is not so angular, it is less, and for more angular aggregate, it is more, right? So these two parameters, after getting these two parameters, I have checked the correlation with UVC, uncompacted void content of coarse aggregate, and it was observed that there was not so good correlation. But it is okay because it is some positive correlation there. Positive correlation was found, and it is good correlation. It is not like excellent, but still it is consistent with the results. Okay, so now coming to the second phase of the study, which was about taking the pavement images directly using vehicle mounted, some arrangement was there. So that we have used good quality camera, I mean 4K resolution camera, and the vehicle was at 50 km/h speed. Now here also we tried to keep constant all the other parameters like daylight and the same time, and also the resolution, luminance, and distance of the camera from the pavement, camera angle, all those things we tried to keep constant. Now so what we have done, like we captured the images. You can see we have collected basically images from 11 sources, 11 different test sections, right? All are constructed by IIT Kharagpur. So 3 different surface courses were there: BC, SMA, and GGRP. Now to ensure the consistency again, we kept the image dimension for all the cases same, 1200 by 1000 pixels. Sorry. So after analyzing the data, it was noted that previously for microtexture you have seen that 5th level of decomposition is giving better result, right? So here 8th level of decomposition correlated very well with the MPD data, means which is observed from the laser profilometer. So here from these graphs you can see that BC, SMA, and GGRB surfaces MPT versus our image-based method I have plotted, and you can see that there are some unusual pixels, right? Some unusual points. In case of SMI, means our image-based indices is giving some unusual peaks. So after analyzing the data very carefully, we could see that these are nothing but some, some change in variation in pixel. It is because of mud and maybe because of water on the pavement, something like that, or maybe even pavement marking. So so for that, what we have done to eliminate this presence of unusual pixels, we have used one method, random forest, like we have used isolation forest method, which is a non-parametric unsupervised ML method to detect these outliers. And after removing these outliers, we could see that again with MPD, the SMI, I mean the surface image characteristics, what we have obtained for the macro-texture calculation, that is very correlating good. And also, for example, like after removing the outliers for BC, a cross correlation coefficient also is that improved from 0.14 to 0.91. Now, finally, I'll be discussing how I have developed the models to predict the mean texture depth and mean profile depth from the image-based indices. So, after plotting for different surface courses, it was observed that for BC, SMA, and GGRB, the relation between SMI and mean texture depth, there is a linear correlation. But in case of MPD, means which is obtained from laser-based method, the relation is deviating from the linearity when it goes to dense to gap graded. So in that case, we have found that a logarithmic model is fitting very well, right? And also we have plotted here the estimated MPD versus the observed MPD, and from the equity line we can see that almost all the data points are coming very closer to the equity line. So our proposed image-based method can capture my macro texture data in a manner similar to laser-based method. Now, this is the final phase of the study, which is about predicting the initial skid resistance uh, from pavement microtexture and macrotexture components. So for that, what we have done, we have collected skid resistance data at 50 km/h using fixed leap approach. And for that, we have used skidometer BV11. And the skid resistance was collected, the data was collected at wet condition. So for that, water film thickness was kept 1 mm constantly, and so we have sprayed some water just below the wheel, and then we have collected the data at 50 km/h. Now we can see that here in the table I have presented all the data from different locations like Odisha and Kolkata, Baharagoda, Jharkhand. So here we can see that there are different surface courses, BC, SMA, and gap graded rubberized bituminous mixes. And the NMS is almost for all the cases 13.2, only for 2. Like for BC, it is 19 mm. So two other parameters were also identified, like to see what is the effect of gradation. So for that, Weibull distribution parameter, where Weibull distribution was fitted with the aggregate gradation curve, and shape parameter and scale parameter were identified. So it was observed that for BC, these gradation parameters are low as compared to the gap graded parameters. And it is also observed when we have collected the SR50 data, skid resistance data at 50 km, then also we have seen that for gap graded, we are getting more skid resistance as compared to this dense graded one. Now, based on these data, all the data, I have developed two models. One is before construction, another one is just after construction, new pavement. So before construction, what are the parameters I have taken? I have taken surface texture index, and that is aggregate micro texture index, angularity index, and gradation parameters, what I have just now discussed, like scale parameter and shape parameter. And for the other model, which is just after construction, what I have taken aggregate surface microtexture and SM, that is surface macrotexture index. Now from both the models, we can see that R square adjusted is very high. Now, one more check we have done, that what is the relation between mineralogy and directly to skid resistance. So for that, two-way ANOVA analysis was done, and we can see that the p-value is very less, which is denoting that there is a very high influence on skid resistance, right? Now coming to the key contributions from my PhD work. So this study proposed image-based indices to determine both microtexture and macrotexture pavement surfaces. For microtexture, the aggregate surface texture index, STI, is introduced and can be obtained through processing SEM images of the aggregate with wavelet decomposition. Now for macrotexture, shape index, angularity index, and Weibull distribution parameters, that is shape parameter and scale parameter from mix gradation, are proposed for macrotexture before construction. After construction, STI value and pavement surface images parameter can be used. Now to determine, now also the study demonstrated that aggregate mineralogical parameters can significantly impact pavement surface skid resistance, relative hardness, differential hardness, degree of alteration, mineral grain size. They are having more influence on polishing resistance of aggregate, and also the long-term skid resistance. So it was also observed that surface coarse mixes with igneous rock origin, they have more more resistance to skid resistance. Now this is all about my work, whatever I have done so far. Now, in the future, my plan is to do like more work on skid resistance guidelines development for India. So for that, maybe more types of aggregates I want to include, and of course, some industrial byproducts like slag aggregate, and even maybe some plastic aggregates, some other waste materials. I will focus on that part. And as I have expertise on payment, expertise on image analysis, I want to see using image analysis, what are the other applications we can do, like distress indicating thing, and other what is the crack development, maybe. So that thing also I can do, or maybe mapping, right, to detect the potholes, severity of rutting, like that. And as a part of my long-term research plan, I want to focus on pavement asset management and obviously life cycle assessment and the life cycle cost analysis. So this is my tentative research plan, but again, I'm open for all the other research projects. And actually, I have one plan that I have submitted to one postdoctoral, this one scholarship for a individual scholarship. Let's see, that is also related, like how it is affecting the skid resistance is okay, but how the aggregate surface texture is generating particulate matter, because it is also very hazardous, right? So that is another plan of my future research. Yeah. Thank you so much.
That was an enlightening talk, ma'am. Now the forum is open for discussion.
Yes. Thank you.
Good morning, Dr. Namanvita.
Yes, sir.
I have a question. Yeah, I have a question.
Yes.
You have been explained that the gap graded mixers exhibit better skid resistance than the dense graded mixers like DC, right? So,
Yes.
what is the possible reason for that?
Maybe for the gap graded thing, the coarse aggregate the aggregate size, coarse aggregate size was more on the top. So that can be one reason, because fine is less, right, in case of gap graded aggregate. That is, I think, I found one cause. It may happen. Otherwise, also for gap graded mixes, we have used PMB. So for SMA, we have PMB, and for GGRB, we have used rubberized bitumen, right? So it may also influence, because VG40 we have used for BC. From the literature and previous studies also, I have found that if it is rubberized bitumen or modified bitumen, it may generate, it may produce more skid resistance.
Okay, ma'am. Thank you.
Namanvita, good morning. Actually, it was a good presentation. This is Sanjay from NATPAC. I just wanted to know, actually, your model is predicting the skid resistance from the newly paid late payments. So how it is going to vary, or how is it possible to predict as the payment gets aged or anything like that? Because the traffic will vary into how this can be carried out.
Yes. So basically, in my study, what we have done, we have only considered just after construction, means just after opening the traffic, we have collected the data within 3 to 6 months, right? So in my opinion, if we can take more time series data, every 6 months, if we can get the data, skid resistance data, by some technique, maybe some image or maybe some other technique, or if you have skid resistance skid trailer, then it will be better to know how it is deteriorating. But for the initial case, as the obviously it will be different because in the initially the bitumen coating is also there, but after some time the bitumen coating will go, right? So obviously it will change. Then microtexture of coarse aggregate will be, I mean, more impactful factor, because the bitumen coating will not be there, right? Only coarse aggregate microtexture will be the major part, which will be in direct contact with the tire of the vehicle. So the time series data, if we can collect, we'll get to know what is the actual deterioration. But for the initial thing, I'm quite sure that this method will work, because here we are taking all the parameters like aggregate, microtexture and pavement macrotexture, what is the effect of gradation, all those factors we are taking care of.
Yeah, that's what, because now due to polishing, this skid resistance also may come down, or even may get increased because due to leveling or other things. So
Yes, yes.
in order to maintain the minimum skid number so well that the vehicles are not skidding. So what would be the way forward? That was what I was thinking of. Fine, thank you.
Hello. Hi, Dr. Napanida. This is Shijit from NATPAC.
Yes.
Yeah, I have a question. Have you considered the effect of environmental factors like temperature and moisture, how these are affecting the skid resistance? Have you considered that part?
No, temperature, it was not my scope of the study. And environment, like rainfall, if you like tell, then in that case, I'll say we have collected the data, during rainy season also, and wet condition, like 1 mm film thickness was there. So that adverse part of the pavement, when it is wet, that we have taken care of. But I mean, that skid resistance data only we have collected. We did not collect the dry pavement skid resistance data. But variation I did not take. I mean, what is the if we, like we can do that, of course, by changing the water film thickness, right? So if we keep 1 mm, 2 mm, then we can actually consider the high rainfall, I mean the moderate or low rainfall, that we did not do.
Okay, fine. Thank you.
Thank you.
Dr. Namita, I have a question. Actually, the mineralogical properties and the morphological properties what you have considered for the aggregate that is used in the experiment investigation, how it is deviate from the aggregate that is you have investigated from the field. So does it have the same what you have chosen? Like you have chosen 3 different types, I guess, right? Granite and
Yes,
quartz and all.
yes,
So,
yes.
so what was the observation like? Whether the deviation was more and can you able to correlate with the experimental
Yes,
investigation what you have arrived?
Yes, definitely. I could correlate, because see, in my case, as I have told you, I have collected aggregates from 14 different sources, and those sources, from the 14 sources, almost 5 to 6 aggregate sources only we have used for the pavement construction, like test site construction. So the same, like using the same aggregate, we have done the test section, and then from that skid resistance data and gradation and other, I mean, data we have collected, macro texture data, whatever be. So also I have seen that as I have mentioned that for gradation it is changing the skid resistance data. Similarly, for as I have taken granite, like metamorphic, which is amphibolite, and other one is basalt. So I have observed that for granite, it is more like the resistance is very high for granite as compared to basalt and amphibolite. Amphibolite has the least one, but again in granite, I have seen one. I have observed one interesting thing, that is, two sources were altered granite. So they are basically not pure granite; they are weathered granite. For that case also, the skid resistance, I mean the polishing resistance was less. the resistance was less, so it deteriorated. I mean, heavy deterioration was found.
Okay, while doing in the lab, actually, the aggregate what we have used is the aggregate that is without coating, the aggregate which is uncoated with the bitumen. Whereas in the field, you would have used the aggregate which is coated with the bitumen, right?
True. Yes.
So there will be a big difference between your comparison and validation, right? So what was the strategy you have followed?
Yes. So what we have found, that's what I told already. I have already discussed that the main point, you are right, that bitumen will have more impact, but the result may change also. But the thing is, after some time, bitumen coating will not be there, right? After some time, only aggregate microtexture plays the major role. So that is why, even from the other studies also, we can see only aggregate microtexture is having more role. I mean, if the coating is not totally gone also, it follows the aggregate microtexture only, that film. So in that way, it is relatable.
Okay, thank you.
Any other questions from the participants?
No, Dr. Namrita, are you continuing with the work or have any program?
No, Professor, I have completed this work, but I want to continue this topic only because I want to see what is the effect of other aggregates like slag and other things, and also similar thing only I am working here as well at IIT Bombay on similar project I am working. So here what we have done, AIMS I am using. So here AIMS is there in this laboratory. No need to check the morphological properties using developed image-based analysis. So here AIMS we are using, and also using microdevel I am observing the polishing, like how it is changing and all. Maybe if we can collect some field data, time series data, as I have mentioned, it will be useful for us. Yes.
Yeah, that's good. And it's a very good work and very good presentation. Do you think that, let's say, the data from different parts of the country is required to make it as a complete one?
Yes, definitely. It will be good, of course. Like if we can take from at least 2-3 sources data from all the region. I tried to collect like the eastern zone I have covered almost. I tried because Jharkhand, Odisha, Andhra Pradesh, Telangana, and Northeast sources I have collected. Right. Obviously, that will be useful. Definitely.
Suppose if you wanted to, make it as a national level code or something like that, probably
True.
data
Yes,
from
sir.
from the
Yes,
various parts
definitely.
across the country is required. Anyway, it's a good work. Congratulations.
Thank you,
Yeah,
Professor.
that all from my side.
Thank you, sir.
I call upon Sri Srijit PP, Junior Scientist at NATPAC, to propose the vote of thanks.
Good morning, all. On behalf of KSCSTE-NATPAC, I would like to express my sincere gratitude for each one of you for joining the 12th TransPedia Research Talks series on the topic Role of Aggregate on Skid Resistance of Bituminous Payments. It has been an interesting and outstanding session. First and foremost, I would like to express my deepest appreciation to our distinguished speaker, Dr. Nabanita Roy, for sharing her valuable research finding with us. Your deep research in aggregate mineralogy and mineral characteristics and their effect on skid resistance is really interesting. And once again, thank you, Dr. Nabanita Roy, for delivering such a wonderful presentation. Then I would like to express my sincere thanks to all the attendees for your participation and interactions. And we believe that our TransPedia Research Talk series is getting beneficial to students, academicians, and working professionals, etc. And furthermore, a big thanks to our director, division heads, and TransPedia coordinator teams for making this event possible. Your support has made it possible for us to come together and explore this important topic. And we request all the participants to attend the upcoming online series of NATPAC. Thank you. Thank you all.
Thank you so much for inviting me. Yes.
This will be winding up the session. Thank you all for joining. Thank you very much.